forgot to record the last problem, but that's okay, since it's not something that's on the final. All right, so question 20 says, find the Taylor series for f of x equals e to the x, centered at a equals 3. Show all work, do not just state the formula. Okay, so here's the formula for Taylor series, right? It's the summation n equals 1 to infinity of f sub n of a over n factorial times x minus a to the n. And I actually think it's n equals 0. I wrote n equals 1, and I just want to double check so that I'm correct here. 1 second here. Yeah, n equals 0. My brain's not totally with it here today. Okay. So anytime if you're asked to find a Taylor series, right, this is kind of where you want to start. And so what we want to start doing is we want to figure out what that f sub n of a is. And so what that means is the nth derivative evaluated at a. So the way to figure this out is to first off take some derivatives and see what is happening. So f prime of x. So what's the derivative of f prime of x? Or what's, I should say, yeah, e to the x. What's the second derivative? Here's where it's bad. I don't know. Yeah, e to the x. I was going to go, I don't know if people's answers are to my first question or to my second question. Yeah, as a matter of fact here, any of the derivatives would keep being e to the x, right? So the fourth derivative, e to the x. Okay, so can you see a pattern? If I want to write down what the nth derivative of x is, the nth derivative of x is just going to be e to the x. And then we want the nth derivative evaluated at a. So in our case, that's our a value is 3. So we want the nth derivative evaluated at 3. So it's going to be e cubed. So our formula is going to be the summation n equals 0 to infinity of e cubed, that's the nth derivative evaluated at a, over n factorial times x minus a, which in our case is 3, times x minus 3 to the n. Does that make sense? Okay, so while we're on this topic, I'm going to do 21 in a minute here. However, before we do 21, let's pull up the problem. So this is a good problem. And let's pull up the problem that was on the third exam, because a lot of you guys did not get this problem right on the third exam. It was not meant to be a super hard problem, but I got a lot of really crazy answers for it. So I need to pull up what it was. Yeah, you weren't alone. Lots of people did also. Lots of people tried weird things. Lots of people gave me weird answers. Lots of people left it blank. Okay. So on the final exam, or not on the final, on test 3. So from test, and I should actually just go to a new page. Okay. So from test 3, this is number 6. So number 6 asked you for the same type of thing. It said, hey, here's f of x is 1 over x. Generated by f of x. Okay, it said at x equal 3. I meant to put a equals 3, but all right. So again, we're going to be trying to plug into the summation n equals 0 to infinity of f sub n of a over n factorial x minus a to the n. So again, the biggest thing is to figure out what the pattern is, right? So I like to think of this, really the easier way to think of this to take the derivative is x to the negative 1. So what would the first derivative of this be? Yeah, negative x to the negative 2. What about the second derivative? Okay, so it's going to be x to the negative 3, but remember the negative 2 is going to come down in front. So negative 1 times negative 2 gives me a positive 2, x to the negative 3. What about the third derivative? Yeah. So the negative 3 is going to come down in front. Now, you could have just written it as negative 6, but it's harder to see the pattern if you multiply these things together. So I have negative 3 times 2x to the negative 4, right? And then if I found the fourth derivative, right? And you can keep going as many derivatives as you need to see the pattern. So if I took the fourth derivative, negative times negative would give me positive, but then I'd have 4 times 3 times 2, x to the negative 5th. And even if I took the fifth derivative, we'd have negative 5 times 4 times 3 times 2, x to the negative 6. So, for me, that's enough for me to see the pattern. One of the things that I notice is that here, when I'm taking a fifth derivative, I have 5 times 4 times 3 times 2. And technically I have times 1, right? I don't have to write it times 1, but I have it. So this is the same as 5 factorial. Here I have 4 times 3 times 2, so that's the same as 4 factorial. Here I have 3 times 2, so that's the same as 3 factorial. And here I have just a 2, so that's the same as 2 factorial, right? And technically, here I have a 1, and that's the same as 1 factorial. So if I wanted to write down a formula for the nth derivative, right, one of the things it looks like is when I have the first derivative, I have 1 factorial. Second derivative, I have 2 factorial. Third derivative, I have 3 factorial. Fourth derivative, 4 factorial. So in the nth derivative, I probably have an n factorial. Does that first part make sense? Okay, so now another thing that I have going on, right, is if you look, this is negative, then it's a positive, then it's a negative, then it's a positive, then it's a negative, right? Because I have a negative in front, I have nothing in front, so it's positive. I have a negative in front, I have nothing in front, I have a negative in front, so it's alternating, right? So as soon as you have it's alternating negative, positive, or positive, negative, it means you have negative 1 to some power, right? And you just have to figure out what that power is. Generally, the power is always either negative 1 to the n, negative 1 to the n plus 1. We just have to figure out which one it's going to be. So if we look, when I have the first derivative, I want negative. The third derivative, I want negative. The fifth derivative, I want negative. So I want all the odd derivatives to end up being negative. So that's going to be n. If I wanted the second derivative and the fourth derivative and the sixth derivative and the eighth derivative to be positive, then that's where I would do n plus 1. Does that make sense? Okay, and then the only other part I have is I have x to a power. The powers are all negative, And again, we're always trying to relate the, like, what derivative we're on with what we're doing. So first derivative, I have a 2. Second derivative, I have a 3. Third derivative, I have a 4. So I always have one more, right? So it's going to be negative n plus 1. One more than the derivative. Does that make sense? Okay, so now I have my pattern. So now all I have to do is find the derivative evaluated at 3, because that's my a value here. So that's going to be n factorial negative 1 to the n 3. And you could leave it as negative n plus 1. If you want to distribute the negative and make it negative n minus 1, that's fine too. And then all I'm going to do is I'm going to plug this in. So we've got the summation n equals 0 to infinity of n factorial negative 1 to the n, 3 to the negative n plus 1 over n factorial x minus 3 to the n. Oops. And in this case, the n factorials would cancel. So really, we have n equals 0 to infinity, negative 1 to the n, 3 to the negative n plus 1, x minus 3 to the n. So does that help on that question from the third test? So a lot of people got that question wrong, right, on the third test. So I wouldn't be surprised if there was a fairly similar question on the final exam. Speaking as someone who wrote the final exam. Yep. I think you guys got my drift there. Okay, so questions on this type of problem, 20 or this one from the test. And then I'll do 21 was the other one, right? Yes, I will be posting the stuff from today. Yep. Okay, so 21 says find a power series representation, so a Maclaurin series for the following. Okay, so A gives us f of x equals 1 over x plus 2. And B gives us f of x equals x cubed over 1 minus x squared. Okay, and so it asks for a power series. So you could attack this problem one of two ways. So one way that you could attack this problem is you could go about doing the same thing we just did in problem 20 and problem 6 from the test. But this time, rather than use a equals 3, we could use a equals 0. The other thing you can do, though, here is these look somewhat, sort of, like some of the problems on that sheet that I handed out. And so that sheet, the series. Oh, you know what? I didn't put them in a sheet. We just wrote them during class. Wait a minute, let me get them then. I was gonna pull up the sheet so I had them. Remember in class I gave a reference for, here's a bunch of different power series. And then I said, you can make new series from these power series. Right? Does this sound vaguely familiar? So some of those series that we wrote were things like this, like 1 over 1 plus x, right, is equal to the summation n equals 0 to infinity of negative 1 to the n x to the n. Right? So you could go about these a couple different ways, right? And let me see how I did it on the review sheet. That way I can explain it the same way. Okay. So yeah. So on the review sheet, all right, so this is the way I thought I did it. So I used this red series. I actually used this red series for both part A and part B. So if we look at part A, actually, before we do part A, let's do a part that's like, we'll call it part extra. So it's one that's not on the sheet. So let's say I gave us f of x was equal to 1 over 1 plus 3x, right? So this looks a lot like this series. It looks a lot like this function. What's the only difference between this function I just wrote, the 1 over 1 plus 3x, and 1 over 1 plus x? Yeah, the 3x. So what that means is I could write this as a series by using what I have over here, this red series, n equals 0 to infinity. But every place I see an x, I would put a 3x. So this would be negative 1 to the n, 3x to the n. And you could distribute the n if you wanted to, right? N equals 0 to infinity, negative 1 to the n, 3 to the n, x to the n, right? So if you wanted to, you could do that. So does that make sense? Let's start with that one. I know it's not one of the ones from the review sheet, but let's just start with that one first. Okay. So now if you look at the first one on the review sheet, f of x equals 1 over x plus 2. So I want it to be similar. The problem is that it's not, this first one here was easy to kind of doctor up because rather than the x, I just had a 3x. So I could just replace x here with the 3x. The problem here is that I have a 2 where here I have a 1, right? And so what I could actually do is I could factor the 2 out of the bottom, right? So if I factor the 2, and I'm going to actually, before I do that, I'm going to rewrite this. So 1 over x plus 2 is the same as 1 over 2 plus x. And so now if I factor the 2 out, I have 2 times. So when I pull a 2 out of 2, I'm left with 1. So think about, I need something here that when I redistribute the 2, I want to end up with 2. So 2 times what would give me 2? 2 times 1. And now I want to write something next to this that when I distribute the 2 times this, I end up with the x. So 2 times what would give me x? Yeah, 1/2 x, or x over 2. Right? So even though there's not technically a 2 in the x term, I can factor it out by making it then x over 2. Does that make sense? And so the thing is that now I can think of this as 1/2 times 1 over 1 plus x over 2. So I haven't done any calculus, I haven't done any series, I haven't done any of that. All I've done is some creative algebra. Right? So questions on any of my algebra steps before then we do the series part, which now should actually be fairly simple. Okay, so if I plug into the series, I'm going to get the summation n equals 0 to infinity of negative 1 to the n. And now I have an x over 2, so I have an x over 2 to the n. And I still had this 1/2 sitting out in front. I forgot about that. And you could leave your answer that way, or we could bring that 1/2 inside. So we'd have n equals 0 to infinity, 1/2 times negative 1 to the n. And I could rewrite this fraction as x to the n over 2 to the n. So this would end up being the summation n equals 0 to infinity of negative 1 to the n, x to the n, and on the bottom I'd have 2 to the n plus 1. Does that make sense? Questions on that one before we do part B? No. Okay, so I'm gonna take this, copy this with us. Let me paste that so we still have it as our reference. So part B gives us f of x equals x cubed over 1 minus x quantity squared. Right? So there's a couple things going on, right? So we know that 1 over 1 plus x is equal to this, right? I could easily make this bottom a 1 minus x instead of a 1 plus x. That wouldn't be hard to do. The problem is this squared, right? So if I think about starting with the function g of x, right, instead of being just 1 over 1 minus x, right, that I know how to rewrite. So that I could rewrite as the summation n equals 0 to infinity of negative 1 to the n, and then I would have minus x to the n. Okay, so this would just become the summation n equals 0 to infinity. I'd have negative 1 to the n, negative 1 to the n, x to the n, or the summation n equals 0 to infinity. I'd have negative 1 to the 2n x to the n. But negative 1 to the 2n, that's always raising negative 1 to an even power. So that would just come out to be even, or to be a positive 1. So this is really all just being equal to x to the n. So I know that's not the problem I was asked for. We're going to get to that problem here in a second. And then, yeah, exactly what Robert said. We're actually going to take a derivative of our function g of x here, and that's how we're going to get that squared in there. But any questions on what I did so far, how I actually got what g of x represents? The second one here, so this negative 1 to the n just comes from my formula. The minus x, that's because my formula is a plus x. So really what I'm doing is I'm thinking of this as 1 plus negative x. So that's how come I get negative x to the n. And remember, negative x to the n we can think of as negative 1x to the n. And so then I'm distributing that n. So I've got negative 1 to the n, x to the n. Does that make sense? Or did I answer your question? Okay. Other questions before we actually get to the answer we're looking for? Okay, so our problem, we're looking for the 1 minus x to be squared. So if I were to take the derivative of g, so g prime of x, so remember, this is really 1 minus x to the negative 1. So the negative 1 would come down in front. So negative 1 1 minus x to the negative 2 times the derivative of the stuff inside, which is times negative 1. So in the end, this is all equal to negative times negative is positive. So this is really just 1 over 1 minus x squared. Does that make sense, how I got found g prime of x? Okay, so I can, to find the series, since I already know that g of x is equal to this here, right? I already know g of x is equal to this. All I want to do is take the derivative of that. So remember, when you take a derivative, if you take the derivative of the constant term, it goes away. So when we take derivatives of series that are starting at n equals 0, like these types of power series, when we take the first derivative, the index 0 goes away because that's the constant term and it's going away. So here we become n equals 1 to infinity, and then x, or nx to the n minus 1, right? So I'm just doing the power rule on that x to the n part. So does that make sense so far? Okay, so now what I want to do is I am at a point where I can figure out what to do with my original function. So if I look at my original function here that was given to me in part B, we're looking for f of x, which we can think of that really as x cubed times 1 over 1 minus x quantity squared. And we just figured out what the series for that is. So this is going to be x cubed times the series n equals 1 to infinity of nx to the n minus 1. So I can take the x cubed inside. So this becomes the summation n equals 1 to infinity of x cubed n x to the n minus 1. Or the summation n equals 1 to infinity of nx. If I add 3 and n minus 1, I would get n plus 2. Does that make sense? Yeah, so that's all there was to that one. So while we're on the topic here, so this is actually very similar to problem 7 on the test. I should say part A was very similar to problem 7. So let's look at that from test 3, because a lot of people did a lot of really crazy things with this problem as well. So from test 3, number 7 gave you f of x equals 3x to the 4th times 1 minus 2x. And I told you in the problem, hey, you could use the fact that the natural log of 1 plus x is equal to the summation n equals 1 to infinity of negative 1 to the n minus 1, x to the n, all over n. So I gave you a piece of information that you could use, right? Oops, and wait a minute, I didn't write this right. See if I can. I'm missing a natural log in here. Right, natural log of 1 minus 2x. Okay, so this was not meant to be a tricky problem on the test. This was actually meant to be one of those like, hey, this should be a really easy problem for people. I'm like practically giving you the answer. Look, here's the natural log part, right? So I'm going to use this series to rewrite the natural log part. So this is going to be 3x to the 4th, the summation, n equals 1 to infinity, And then the only difference between what I have here in red and over here is that instead of a plus x, I have a minus 2x. So that's all we had to do, is wherever there was an x, instead of x, we just had to put minus 2x to the n all over n. So does that make sense so far? Okay. So some people got to this step okay, and then you did a bunch of crazy stuff to get it all together. So the first thing I'm going to do is I'm going to pull the 3x to the fourth inside. So we're going to have the summation n equals 1 to infinity. So I'm going to have 3x to the fourth. I have negative 1 to the n minus 1. I'm going to break apart the negative 2x. So we can really think of negative 2x as negative 1 times 2 times x. So this would be negative 1 to the n, 2 to the n, x to the n, all over n. Does that make sense? Okay, so now I'm going to put together things that I can. So we're going to have the summation n equals 1 to infinity. Okay, 3, I cannot multiply 3 times anything. I got a lot of 6 to the n's, or I got a lot of just 6's. You can't multiply this 3 and the 2 to the n, because the 2 is to the n power and the 3 is not. So the 3 just has to stay. So I have 3. I could put together my two negative 1's, right? So I have negative 1 to the n minus 1, and I have negative 1 to the n. So I could put them together as negative 1 to the 2n minus 1, because you have n minus 1 plus n, so that's 2n minus 1. I have a 2 to the n, and then I have x to the n plus 4 more, all over n. So that is a completely fine answer. If you had done that, I would have taken it. Some people from this point did recognize that 2 to the n minus 1 is always going to be an odd number, because if I take 2 times any number and then I subtract 1 from it, I'm always going to have an odd number. So you could have done one final step here if you really wanted to and made this n equals 1 to infinity of 3 times negative 1, 2 to the n, x to the n plus 4, all over n. But you didn't have to do that step. It's kind of up to you. Does that make sense from that problem? I got a lot of answers that still had natural logs in them and all sorts of other, I had a series, and then within the series there was a natural log, so all sorts of kind of crazy things happened in this problem. No? Okay. Other questions about the final? I should say I will have office hours next Monday, so the day before the final at 4 p.m. So, you know, I will have regular office hours that day as well. So I just won't have office hours tomorrow or Thursday. Section 10.3, numbers 6 and 7. All right. No problem. Those are good questions to ask about. I should say too, right? Like, test 1, test 2, test 3 make up the bulk of the final exam, right? So there's not a lot of stuff of the newer stuff on the final exam. I mean, it's there, but you definitely want to make sure you can do the stuff from all the old tests, right? So, oh, that's right. I didn't give you guys the formula for the length. That's why you can't do 6 and 7. It's just plug and chug into a formula, so don't worry about 6 and 7. I forgot to give you guys that formula. I had stopped us before that. Sorry about that. I should have went back and changed that homework. I don't think it's Planck's formula. It's just a formula for arc length in polar coordinates. So the formula for arc length, I can tell you what it is. I have to look it up, but the formula for arc length in polar coordinates is the oh, that's okay. So if you were interested in 10.3 for 6 or 7, you would need how to go from theta squared to theta squared. You're saying in the answer, Sandra? So the formula I used is this. The length is equal to, so whatever angles you're starting and ending at, from alpha to beta, of the square root of r squared plus dr d theta squared d theta. Right? So let me look at my answers so I can try to figure out what you're asking me. Well, I did. So, okay. Yeah, I mean, the two I have out in front is coming from. Oh yeah, I did use a different formula than this, didn't I? I don't know. What formula did I do? Yeah, I don't know why I don't know what formula I used on that. I didn't use the formula I would have used. Oh, yes, I did. Okay, I'm looking at the wrong problem. Like, there's no square root. Okay, yeah. So I did, oh, so like you're saying in 7. Like in number 7, there's like magically a 2 in front, right? That's the one you're asking me kind of about. I'm just using symmetry. Like, that's why there's a 2 in front in number 7 because I basically am just using symmetry to cut down on the amount of work that I had to do. In 6, yeah, in 6 there's not a 2, but in 6 you get a 1/2 in doing the u substitution in the integration. But yeah, the 2 in number 7 comes from basically 1 plus cosine of theta. I'm using the fact that, so 1 plus the cosine of theta, that's one of the cardioids. And so basically I'm just finding half of it and then doubling it to get the whole length. If you want to stick around at the end of class, I'll go over it. I don't want to go over it right now because it's not stuff that's on the final exam. But I'm happy to go over it with you. No problem. Other questions people have about the final exam? So I would for sure make sure you know how to do all the different techniques of integration, right? Integration by parts, integration by trig substitution. Just like before, right? I will give you that paper for the trig substitution, like with the different, like the reduction formulas and that stuff. I will give you, and the identities, I'll give you that same form as I did, that same, reference sheet as I did before. But I would for sure know how to do all those techniques of integration. I would know how to do the series tests, right? I think all the questions on the last exam were good questions. So, I should say all of the questions on all 3 exams were good questions. So, I would definitely look at, making sure you understand how to do all those questions from the exam. And yeah, there's not a ton of new stuff. It's mostly the old stuff. No, so you don't, so even though that's on the review sheet, remember I said you don't have to do that. So the area, the very last thing of the review sheet, the area between 2 curves, you're not going to have to be able, you don't have to do that. Other questions? Okay. Let me see. So, which question from 10.5? Because some of the 10.5 stuff could potentially be on the exam, right? Being able to find the tangent line is definitely a good question for the final. So, okay. So how do I find... so the video will be available either later today or tomorrow. It depends kind of how long it is. So sometimes the video goes... It just depends how long it takes for it to buffer and get up and stuff like that. So it will be up, I promise. No problem. Okay, so 10.5, number 4. Okay, so number 4 gives you x equals 2 cosine t, y equals 2 sine t, t equals pi over 4. And they ask you to do 2 things. I asked you to do 2 things. One, I asked you to find the tangent line. So find the tangent line at the t value given. And the second one was to find d squared y over dx squared. Okay, so first we have to find dy over dx. So to do both parts, we have to find dy over dx. So remember, dy over dx is equal to dy over dt divided by dx over dt. So what is dy over dt? Yeah, so dy over dt is minus 2 sine t. And what is that's dx dt, right? So remember, dy dt, so the derivative of 2 sine t. No, that's okay. Yeah, so this is minus 2 sine t is dx dt. And dy dt would be 2 cosine t. Yep. Okay. So that's the only part we're going to need to find the equation of the tangent line here in a minute. We'll do that in a second. But while we're doing it, let's find the second derivative, right? So dy squared over d, d squared y over dx squared, right? So it's going to be, you can think of this as like y prime, right? So it's going to be dy prime over dt. So take the derivative of what we just found with respect to t. But then we also have to divide by another dx dt. So the bottom is going to be another minus 2 sine t. You could do a couple things. So one thing you could do is you could take the derivative of this as it is, or we could do a little bit of algebra to make something easier to take the derivative of. If I took the derivative of this as it is, I'm going to have to use the quotient rule. So it's kind of like, do you want to use the quotient rule, or do you want to make it simpler and not deal with the quotient rule? So I'll leave it up to you. Which would you prefer to do? Okay, so if we do it the simpler way, so remember the 2's here would cancel, and then what is cosine over sine? Yeah, so cosine over sine, so this is going to be negative cotangent of t. So now we need to take the derivative of cotangent of t. So remember the derivative of cotangent of t is negative cosecant squared of t. So this in the end is cosecant squared t over 2 sine t. Or you could rewrite it some if you wanted to. Cosecant, remember, is 1 over sine. So you could write this as 1 over 2 sine cubed of t, or you could have written it as 1/2 the cosecant cubed of t. Any of those answers would be fine. I would take any of them. It doesn't really matter to me which one you do. So does that help in terms of the second derivative? Okay, and then just in case anybody else is, hasn't done this homework, wants to see this, to find the equation of the tangent line, right? So to find the equation of the tangent line, I need a point and a slope. So to get the point, all we're going to do is plug this t value into my x and my y. So x is going to be 2 cosine pi over 4. Y is going to be 2 sine pi over 4. So 2 cosine pi over 4 is 2 times root 2 over 2, or root 2. And 2 sine pi over 4 is 2 times root 2 over 2, or root 2. And then the derivative, right, so the slope is going to be the derivative evaluated at pi over 4. So it's going to be minus the cotangent of pi over 4. And the cotangent of pi over 4 is 1, so this is going to be minus 1. Oh, yep, I dropped the negative, so this should all be negative. All of those answers should be negative. Sorry about that. So now that I have point and I have the slope, I'm just going to use point slope form. So y minus root 2 equals m negative 1 times x minus the x value. So x minus root 2. Does that help for that one? No problem. Other questions? No. All right then. So like I said, right, Brian will do an SI session on Thursday. I will not be here on Thursday. And then after that, I'll have office hours on Monday. So if you have questions, you can swing by my office hours on Monday. You can email me anytime you have questions. And then the final will be next Tuesday.